So section 8.1, Pythagorean theorem and its converse, and our objective is to use both of those theorems and converses. Theorem 8.1, Pythagorean theorem. If the triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So for this one, again, you can have the title, you can have the words, and you can have that little equation there. A squared plus B squared equals C squared. The main thing you have to remember is to use the Pythagorean theorem, it has to be a right triangle. So you might want to put a little box or something around that. If it is an acute triangle or an obtuse triangle or whatever it happens to be, you cannot use this theorem. A Pythagorean triple is a set of non-zero whole numbers that satisfy the Pythagorean theorem, a squared plus b squared equals c squared. Some examples are a 3, 4, 5 triangle. With that one, if you know it's a 3, 4, 5 triangle, you don't even have to do anything else because it is automatically a right triangle. The only other one that I actually have in my head are 3, 4, 5 and 5, 12, 13. The 3, 4, 5 is the most common one, but 5, 12, 13 gets used a lot. And if you do 5 squared plus 12 squared equals 13 squared, it does give you a true theorem. 8, 15, 17 isn't a super common one, and there's a whole bunch more. Basically, they're numbers that automatically tell you that it's a right triangle. For instance, if you are outside and you measure 3 one way, 4 the other way, and you connect it, that'll automatically be 5. Or if you make it 5, you know that it's a right angle there. So basically, if you don't have something that tells you the number of degrees, if you make a 3, 4, 5 triangle, you will know automatically that's a right angle there. So you can get by, you know, in other places without a protractor or something like that. Okay, so first question, what is the length of the hypotenuse of the triangle? Remember, the hypotenuse is always opposite the square. That, excuse me, that is always the longest side. And then it says, do the sides form a Pythagorean triple? So on this one, it doesn't matter the order. 20 squared plus 21 squared equals c squared. So 20 squared is 400. And if you want to grab your calculator for a second, we're going to type this in kind of all in one. As long as you have 20 squared plus 21 squared equals c squared, you don't have to tell me and simplify the rest of it. If you wanted to, 20 squared is 400. If you wanted to put the next one in is 441, but your calculators kind of do it for you. So type this in with me. Do 20, hit your squared key, plus 21, hit your squared key, and then do equals. Okay, this is the part you actually need to do. So I'm getting 841. So if you give me the total there equals c squared, then how do you get rid of something squared? Square root both sides. So c is going to equal the square root of 841. Everybody know where the square root key is on your calculators? Make sure you know. If you don't, let me know and I'll show you. We're going to square root 841. And it is 29. Now really, when we are solving things and we get to a point where you're going to square root something, you really have two answers. One can be plus, one can be minus. But when you're talking about length, can you have a negative 29 length? No, so really on these, we're only going to use the positive one unless it's talking about some random equation that they already have the square root in, then it's only the positive answer. So I'm going to only use 29. The other thing that I've seen people do is they're going, oh, I'm going to add 20 and 21 together, and then I'm going to square it. So I want you to do that really quick. Do 20 plus 21, that would be 41. Is 41 squared the same as 841? Guaranteed it probably isn't. 41 squared is 1681. So if you guys are doing problems and you are getting every single one of them wrong, and you swear you're doing this right, it's because you are adding them first and then squaring them. You have to do each one separately and then add them together. So 20 squared on your calculator plus 21 squared on your calculator, and then you can go from there. Oh, last thing, do the sides form a Pythagorean triple? 20, 21, 29. They do if it actually comes in as a whole number. If, for instance, you had 20, 21, and 65.2, then it's not a perfect Pythagorean triple. So for this one, the answer is yes. Okay, so grab a piece of paper, and I want you to try this got it number 1 question. Put it at the top of your assignment, please. So the legs of a right triangle have the lengths 10 and 24. What's the length of the hypotenuse? Remember, the hypotenuse is always the C part, so we just put those numbers in any spot. You could do 24 squared plus 10 squared or 10 squared plus 24 squared. You still get the same thing. When you add their squares together, you get 676. When you take the square root of that on your calculator, you get a 26. So do the sides form a Pythagorean triple? They do. So I'm going to show you one more thing that will help you to decide if it's a Pythagorean triple. So this one was 10, 24, 26. If you actually look at this, and these are multiples of 5, 12, 13. Remember how we did 3, 4, 5? And then the next one was 5, 12, 13. If you divide all of these numbers by 2, you get 5, 12, 13. So any multiples of 3, 4, 5, 5, 12, 13, or any of the other ones they had listed, if they're multiples of those numbers, it does work that way as well. So with this one, they took that 5, 12, 13 triangle and they multiplied it by 2. They just made it 2 times bigger. So this one is yes. But the other way that you can tell is if you have an exact answer for C, not a 26.7 or a square root of a long decimal numbered thing. Sometimes, and you can ignore this part right here, sometimes they actually give you something that isn't the hypotenuse that you're looking for. So on this one, it's a right triangle, so we can use the theorem. But remember that the side that's by itself is the one that's opposite the square. So it is not always going to be 8 squared plus 20 squared equals x squared, or 6 squared plus 7 squared equals the hypotenuse length squared. This time the 20 is by itself. The other 2 squares are added together. So x squared plus 8 squared equals 20 squared. So just pay attention at where those numbers are. This time the 20 is the longest side, and that's by itself. So if we square each of these, we get 64 and 400. I'm going to subtract 64 from both sides. What is that, 336? And then square root both sides. Since it's talking about length, I'm not going to do the negative one. So the square root of 336 is about 18.33. Is this a Pythagorean triple? No, it is not a multiple of 3, 4, 5, 5, 12, 13, or any of those others because it's a decimal. So this one is not a Pythagorean triple, but they didn't ask for it either. On this one, the book, I think, will ask you to simplify the answer and put it in radical form. I want to show you that because on the last, I can't remember if it was the quiz or the test or whatever, many people did not know how to do that or didn't remember it. I know you did it in Algebra 1. So when you look at 336, we want to find numbers that go into 336. It does not matter which one you pick because you're going to go all the way to the bottom and decide, how to simplify it. The book will say, try to find perfect squares that go in there. If you do that, it's easier. So what are perfect squares? 2 squared, 3 squared, 4 squared, 5 squared, and so on. So 2 squared is 4, so does 4 go in there? Or 3 squared is 9. Does 9 go in there? Because then you know it does have a perfect root that comes out. But if you don't remember those, it doesn't matter. Okay, so I'm going to show you how to do it a different way than the book, just so that you know there is another way. So 336, if you just divide it by 2, you get 168. And it doesn't matter what you start with. So 2 times 168. 168. I'm going to go 4 times 42. Keep going. 42 is 6 times 7. And 6 is 2 times 3. Now, what I'm going to do is I'm going to list all of those factors along the bottom, and then I'm going to start pairing them and putting them together. So I have 1, 2, 3, 4. I've got 4 2s, a 3, and a 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I think I have them all. So anytime you have 2 numbers that look the same, you can throw a circle around them. And what happens is that comes out as a 2. Because what's the square root of 4? 2. That's what you're kind of thinking of. So anytime you have 2 numbers that look the same, you're going to bring that number out. But when you're bringing it out, you're bringing one of them because you're taking the square root of that. So for this one, we have 2 2's on the outside in which you multiply. And any numbers that do not have circles around them stay in. So this one would be 4 square root 21. Okay, so things that do have perfect squares come out. Things that don't stay in. Now I want you to do this. Take your calculator and do 4 times the square root of 21. Or square root of 21, hit your equals, then take it times 4. You can do it either way. You should get the decimal that we just got before. Okay, so if you have to, that's what you would do if the book is requiring a simplified root or radical rather than a decimal. Usually when I do them, I like to go to the decimal because then you can kind of tell, do I have it kind of right? Okay, so here's what I'm talking about. When you're looking at this 18.3, these 2 numbers better be under that 20 because the 20 is the longest side, right? So when you're looking at the square root of 336 or 4 squared of 21, who knows in their head what 4 squared of 21 is? We don't, do we? So that's why I kind of like to go to the decimals for these rather than the simplified radicals. Not that it's not important that you know how to do it, but I think when you're looking at it and you're trying to figure out, does my answer make sense? The 18 number is far easier to make sense of it than 4 squared of 21. So I generally will have you go 2 places or 1 place or whatever it happens to be. So let's look at another one. The hypotenuse of a right triangle has length 12. One leg has length 6. So the hypotenuse is the C part. So it's 6 squared plus x squared or a squared, whatever letter you want to pick, equals 12 squared. So here's what we're doing. I'm going to show you kind of a little bit different way to do this one, just so you don't have to write as much down. 12 squared minus 6 squared. 144 minus 36 is 108. And then we'll just go to 2 places. So square root of 108 is 10.39. Okay, so hypotenuse is the C. Either of the other 2 can be put in any spot. Okay, dog agility courses often contain a seesaw obstacle. To the nearest inch, how far above the ground are the dog's paws when the seesaw is parallel to the ground? So they have a little triangle drawn there. What's the hypotenuse length there? And we'll call the unknown, we'll call that x. Is it x 26 or 36? 36, and it's always opposite the square. So x squared plus 26 squared equals 36 squared. You have to write the equation down to get full credit on these. Then you can kind of do whatever you want to. If you know that this is 36 squared minus 26 squared, great. It doesn't matter that you write that part down because I know that you've done these before. And if you know at the end that you're taking the square root, just write it. So 36 squared minus 26 squared is 620. And if we take the root of that, 24.9. Now, when you're done, does that make sense? If the longest side is 36 and the other two sides are shorter than that, it does make sense. Okay, so it must be just about 25 inches off the ground. Okay, I'm going to skip that one. You can use the converse of the Pythagorean theorem to determine whether it's a right triangle or not. What you're going to do is you're going to put it into the theorem with the intention of trying to figure out if it's a right triangle first. If it isn't a right triangle, then you have to decide what it is. Is it an acute triangle or is it an obtuse triangle after that? So we're still looking at the same thing, but remember when you put this into your notes for your theorems, you can have those two things. If the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then it's a right triangle. And you guys kind of knew that before. Okay, so here's what we're going to do. All they're asking for this time is it a right triangle? So we don't have to do the other two yet. Now, if they give us 85, 84, and 13, which one is C? The 85, the longest one. Doesn't matter where you put the other two, but you got to go through and go, oh, it's going to be 13 squared plus 84 squared. And it might equal, I'm putting a question mark up there, 85 squared. So what we're going to do is we're just going to square those numbers out on the left, 13 squared plus 84 squared, and you can do that on your calculators. I get 72.25. Is that equal to 85 squared? Okay, if they are indeed the same number, then yes, it is a right triangle. Your explanation is what I have there. Okay, so you've put it into the theorem. It actually works. So all you're going to say is yes. You can say yes by theorem, whatever this one was, 8.2. But if you have the work shown, you don't have to explain. It's already there. If those two would not be equal, then we have to do something else. But on this question, we don't know what that something else is yet. Okay, let's try this next one. Got it, number 4. You can put this one on your paper also. So a triangle has side lengths 16, 48, and 50. Is the triangle a right triangle? So at the end, you're going to say just yes or no. And then you can be done with that one. Okay, so what do you think? Is this a yes or a no? No. Okay, so I'm going to show it to you. 50 is the biggest length, so I'm going to put that one as C. 16 squared plus 48 squared might equal 50 squared. You guys already said it doesn't, so we'll see. 16 squared plus 48 squared is 2560. You can do them separately and then get the answer if you want to. Just add them at the end. Do not do 16 plus 48 and square the answer, because remember that doesn't work. 50 squared is 2500. They are not equal, so this one is no. And if you wanted to give a reason, theorem, what was it, 8.3? 8.2. Oops, here. Doesn't follow the Pythagorean converse. Now, what do we do if it is no? If it is no, then they're going to say, okay, then is it an acute triangle or an obtuse triangle? And how do we know how to do that? So theorem 8.3, if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then it's obtuse. If you want to just say obtuse, and I will let you put this on there, and that, you can. So if you have your theorems written and you want to write that in there, go for it. If c squared is greater than the sum of the other two lengths, then it's obtuse. To me, what that's saying is your c is really long, right? If your hypotenuse is greater than the other ones, so it makes sense, then it's an obtuse triangle. If your C is smaller than the other two lengths, that means your C is kind of short. And then it would be an acute triangle. So for these two, you probably already have this down. If you want to put those other two things, go for it. Same on this one. If you have an acute triangle, if your C is really short. And that's what you're going to do. So on this last one that we did, let's go back and decide what that one was. Okay. On this one, our length, our C is 2500, but our sum of the squares is 2560. Is our C long or short? So this one would be acute. Okay, so let's do a couple more just so you can kind of see them. So we have 6, 11, and 14. Is it acute, obtuse, or right? You always put it in like it's going to be a right triangle, and then if it isn't, that's when you decide what it is. So 6 squared plus 11 squared equals 14 squared, maybe. I'm going to separate these just so you remember that you don't add the numbers together and then square it. So we get 36 plus 121. And 14 squared is 196. So we have 157 and 196. Okay, now on this one, I know that they don't equal each other. Okay, but let's figure out what they do. The 196 is my C part, so the 196 is longer. Is it obtuse or acute? It's obtuse. So if that's kind of the way you think about it, I think it'll be pretty easy, and you won't even probably have to look at the theorem that you have written down. So if your C is longer than the sum of the other two, then it's obtuse. If it's shorter, then it would be acute. And you don't have to use any theorem or anything like that as long as you show, you know, this. The only line you could probably skip is that middle one. But I do want to see the 157 and the 196 in there. Let's try this one. Got it, number 5. Is a triangle with side lengths 7, 8, and 9 acute, obtuse, or right? And then show why. Okay, so we have side lengths 7, 8, and 9. 9 is the longest one, so we'll put that one by itself. 7 squared plus 8 squared might equal 9 squared. So we have 49 and 64. And when we put those together, we get 113. Is 113 bigger or smaller than 81? Bigger. So that means my C length is shorter, right? Which makes it what kind? Acute. So if you always put the sum on the left and the C part on the right, what you're looking at is your C compared to the other numbers. If the C is longer, it's obtuse. If the C is shorter, it's acute. If it equals it, it's a right triangle. So you might have a combination of all of these when you're actually looking. So the main goal today was, how do you use the Pythagorean theorem? How do you decide if it's a right triangle? How do you decide if it's a Pythagorean triple? And then if it isn't a right triangle, then what is it, acute or obtuse?